So for chapter 3, I was in charge of segment 2. This starts out by explaining how electrical signals allow neurons to receive information. There's a voltage difference across the membrane which changes constantly. Positive sodium ions can only enter the membrane when neurotransmitters attach to receptors at gated ion channels, and neurons always maintain a resting potential. As opposed to receiving information, neurons can also send information. This requires an action potential, which briefly reverses their potential to send an electrical message from cell body to tips of the axon. Makes the inside of the neuron more electrically positive than the outside. Depolarizing is the reducing of polarization of a neuron, making it more likely to fire. They fire when they reach the threshold, which is the size of depolarization necessary to trigger an action potential. Positive sodium ions enter, which depolarizes the neuron and brings it closer to the threshold. Excitatory synapses allow positively charged ions to enter. Inhibitory synapses allow negatively charged ions to enter. Hyperpolarizing takes place when by increasing the polarity of a neuron, making it less likely to fire. An axon hillock is the widest part of an axon where it originates from the cell body. Action potential travels from the axon hillock to its tip. The action potential reaches every terminal if there is more than one. All or none property is the fact that the size of the action potential is independent of the size of the stimulus. Action potentials are similar to flushing a toilet. For example, it takes a certain amount of pressure to push the toilet lever in order to make it flush, just like it takes a certain amount to reach the threshold. Also, no matter how hard you push the lever, the flush will always be the same. Once the neuron has passed the threshold, the action potential will always be the same as well. The refractory phase is a period during and immediately after a nerve impulse when a neuron cannot produce another action potential. So similar to a toilet after flush, you have to wait a couple seconds for it to flush again. Well, when a neuron is fired, you have to wait about a millisecond before it can fire again. Myelin is important because it speeds up action potentials. The action potential travels faster in thick axons as opposed to thin. Myelin itself is the fatty insulation around an axon formed by glial cells, which increases the speed of conduction of nerve impulses. Nodes of Ranvier, regularly spaced breaks in the myelin sheath of an axon. Saltatory conduction is the form of conduction in which the action potential jumps from one node of Ranvier to the next. In the brain, we have white and gray matter. White matter is parts of the brain that contain myelinated axons, and the gray matter is brain regions filled with neuronal cell bodies because since they appear to be darker, they look gray. Multiple sclerosis is when the immune system attacks myelin, disrupting action potential conduction and causing various sensory and motor problems. What happens when the action potential reaches the end of an axon? Well, every synapse converts an electrical signal, the action potential, into a chemical signal, neurotransmitter, and then converts it back into an electrical signal. As the receiving cell is electrically excited or inhibited by the entry of either positive or negative ions. Obviously, we know that drugs also affect brain signals and therefore the mind. An agonist is a drug that activates a receptor in the same way as the neurotransmitter. An antagonist is a drug molecule that interferes with neuronal signaling by preventing a neurotransmitter from binding to its receptor. Hormones affect the brain too. Hormones are chemically released from one part of the body that enter the bloodstream and affect other parts of the body. Endocrine glands are glands which release hormones, and the pituitary gland is an endocrine gland that releases hormones that affect virtually all other endocrine glands. That is all.